So, with escalating costs to build housing, further harmed by expanding tariffs and other political or global events that are crashing into the lack of housing that we've been suffering from for a while to meet our needs, how do we ensure that we have affordable housing for all that still reduces impact on the environment, improves people's health, and reduces utility costs and carbon emissions all at the same time? These things are not easy, but it can be done if we change our mindset and our thinking on how we build and how we renovate our housing stock. This is a topic we're excited to discuss today and to continue to discuss in the future, so please join in on this conversation. Now, before we get started, we want to say thanks to our sponsors who allow us to do what we do, our board of directors, our volunteers as well. And so a big shout out to them and thanks for them for having products and services and processes that help achieve sustainable outcomes within the housing sector. This session is brought to you by the Green Home Institute. The Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. Today, I will be a session moderator, one of a few session moderators. My name is Brett Little, and I am the education manager here at the Green Home Institute. But we also have another session promotional partner with ACES. So Ella, why don't you explain ACES a little bit?
Yeah, absolutely. Thank you so much for joining today's webinar, and thank you, Brett and the DHI team for hosting and for being amazing partners. I'm Ella, and I'm the Programs Director at the American Solar Energy Society, ASES. We are a 501c3 nonprofit dedicated to solar advocacy and awareness. We've been around for over 70 years, and our three main programs is our National Solar Conference, which this year is taking place on August 4th through 6th in Boulder, Colorado. I hope you all can join. Our National Solar Tour, which I'll dive a bit deeper in on the next slide, and our quarterly magazine called Solar Today. Our mission is to accelerate equitable solar adoption and universal sustainable living by educating and building community. But next is our National Solar Tour. So I'm excited to share that this year marks the 30th anniversary of the National Solar Tour. This event is the largest annual grassroots solar event, which includes renewable energy and sustainable living, energy efficiency, etc. Tours are hosted by homeowners, businesses, organizations, and who essentially post their tour on the National Solar Tour map, either in person or virtual. ACES provides a platform, support, and promotion, along with resources for tour organizers. We get thousands of people to attend, both virtual and in person, all throughout the year. And please be sure to check out the map to either attend or host a tour anytime. Please note that while anyone can host or attend a tour throughout the year, we have our main showcase weekend this year on October 3rd through 6th, which is right at the beginning of National Energy Awareness Month. Thank you all so much, and I'll pass it on to Debbie up next.
Hello, everybody. Welcome. And thank you so much for American Solar Energy Society for instigating this educational webinar. And thank you, Brett, with the Green Home Institute for hosting and promoting it. I'm Debbie Coleman. I'm involved with both organizations. I'm passionate about both of these nonprofits. And as an architect that specializes in passive solar and always advocating for small homes, I'm happy to help organize this webinar to promote those ideas further. I was excited to find Cillian's projects that incorporate affordable, sustainable. So when I saw his projects, especially the ones for Habitat for Humanity and then the one on the Hopi nations, I just knew we had to get him on the show to share the information. So thank you, Cillian, for your time and looking forward to hear about your projects.
All right, and right before we get started, just a quick reminder that this session, like many of ours, is approved for multiple continuing ed, including all 5 pillars of green and our certified green home professional designation. AIA Health, Welfare, and Safety may make it applicable to your state-based design or contractor license. Look for that 5-digit passive house code. As long as you've stayed for the entire CU hour, you'll get it on the certificate at the end of the session. So yeah, with that, I do want to welcome here our main speaker today, Cillian. I'm really glad you could join us, and please go ahead and take it away.
Well, good morning, afternoon, everyone, wherever you are. Thank you for putting this together, and thanks for all your work running up into this or up to this presentation. My name is Cillian Liam Barrett. I'm the principal of Hearth Design Build based here in Almont, Colorado, up in the mountains. I'm originally from Ireland, trained as an architectural technician, but I've been in the US since 2007, and I've worked all over the country in a variety of different locations, but predominantly in cold climates. So Alaska, Vermont, even Hopi and Arizona. Hopi lands in Arizona was fairly cold too, but now I'm in close to Crested Butte in Gunnison, Colorado. The focus of my company in the last 10 years has specifically been affordable, ecological, and socially minded housing. And I've been lucky to work for and work with a lot of great organizations, which will feature in some of these projects today. Habitat for Humanity is the last one that I've worked with, and so these projects are kind of going in reverse order. So to get started, we'll start with that. Habitat, if you guys aren't aware, in general, Habitat provides affordable housing for folks who are lower income with a kind of a sweat equity model. And most of the organizations of these projects that are going to be featured today were similarly based. Habitat historically has provided like very affordable housing, and while the process has been good, it's not historically had a focus on environmentalism. And as in general, the construction industry hasn't necessarily been able to take account for its impact until relatively recently. And so when Hearth started partnering with Habitat for Humanity in Gunnison in 2019, the impetus was to build a straw bale house for some homeowners that in particular that wanted it. So it all kind of came together. And this slide is the first house that we built. It's a straw cellulose hybrid, because due to our quite cold climate, for those of you who are particularly into the weeds in terms of nerdy terms, this would be about an 11,000 heating degree day climate. And so a single straw bale, in terms of like its performance value, wasn't really quite enough for the performance goals we were getting. And so we have a standard stick frame with cellulose insulation and a straw bale added to it. Again, the other projects, particularly one on Hopi, it wasn't quite as cold a climate, so that wasn't necessary. And as it happened around the time that we were doing this project, Habitat for Humanity as an organization was starting to focus more on ecological impact, and we were fortunate enough to be a recipient of a couple of their awards for 2 consecutive years in a row with our builds. Yeah. So again, this is that same house. So we set out some pretty high goals for ourselves for this house. It was a 2-bedroom, 1-bath house. The homeowners were very committed to the project and the ethics and the ethos of it. This house, our goals were to have it be net positive, and not just in an electrical sense, but in a general sense. We're like, okay, how can we build a house that actually has the most amount of impact in general? Part of the philosophy that our company had developed is something called resource conscious construction. And so rather than just saying like, how can we have this be electrically, solar positive, or how can we use local materials, or how can we keep our money locally, we try to invoke all of those, if not more, and kind of look through that lens, similar to like triple bottom lines, but also looking broader at a broader spectrum of impact, such as people's time, goodwill, or water, soil, local material, all that kind of stuff. And so that was a big part of how we came up with the program for this build. So part of our reasoning was if we reduce our energy use to kind of passive house levels, we'll actually be able to have excess solar that not only is available to the community, but also to the homeowners. And so when we say net positive, specifically with electrical, this home had such a low heating load that the homeowners recently were able to purchase a secondhand electric vehicle and drive about 50 miles a day on average on the excess energy produced by an average size. So this is a 5 kilowatt system, but we're not just looking at like, how we can just have our impact as a bill, but like how to create more of a homestead in terms of our impact. And so, like I said, with a relatively affordable secondhand EV these homeowners are also now to commute to their work and still have basically just paying the electrical connection fee for being grid tied. The interior of the house has all clay and lime plaster finishes. These are all made from local materials, either within Colorado or actually within the valley itself. The 80 to 85% of the lumber used in this building was harvested from within 50 miles of the building site itself. And the majority of the plaster was also from within the valley. The wood you see in the ceiling was harvested again within 50 miles. We tried to avoid as much engineered wood as possible, the exception being the trusses. And so Habitat has this program or a collaboration with the We Build program in Crowley Correctional Facility. And so they actually provide low-cost cabinets as well as structural members for the roof. But apart from that, everything was locally sourced, and we actually processed a lot of stuff on site as well. We're looking south in this picture, so we definitely were very cognizant of the sun when we were building this, but we weren't relying upon, I wouldn't call this a solar house so much as it is taking advantage of the views and the sun. Basically, the way we design our houses, we have the philosophy that in general, we need to focus on the envelope and high insulation, build it tight, insulate it right. And we basically have focused on that because not every house gets great solar orientation. And so if we have more of a envelope system, then we can make it more adaptable to different sites versus being like, oh, we have to have it's facing south and it has to have all this solar gain. So actually, in this house in particular, we have really high performance passive house certified Alpine windows manufactured in the Front Range of near Denver. And we do actually have an average basically sunblock and like a low solar heat gain, just so we don't overheat in the summertime because the envelope itself performs very well. This is a view looking from the kitchen back into that living area. This is a pretty small, this is a 2-bedroom, 1-bath house, and so it's a very compact design. Every project you learn new lessons, and so if I was to build this again tomorrow, I'd probably increase the size of the footprint by a couple of feet in either direction just to give it a little bit more room. But what you're looking at is either all the material is either recycled, all those doors are reclaimed from Restore. Again, like so, most of the natural materials you can see are from the site or from within 50 miles of the site. And the homeowners did a beautiful job of picking colors and decorating. And if we look actually to the left, we can just see the louvered door. That's actually the laundry closet. It's a very compact design. Later on, we'll see a footprint of the 3-bedroom, 2-bath version. So it's very economical in terms of its size, which is about 900 square feet. And so that's part of like where the high performance comes from. And it's, I'll just give a shout out for efficient size housing is no matter how efficient you make a house, the smaller you make it, that's the easiest way to save on energy and definitely cost and materials. We chose to have less openings and then larger ones to save cost and also thermal bridging and heat loss. So the bedroom here, for instance, only has one window that's 6 foot wide by 3 foot tall. So lots of light. We angled the window jambs because it's a very deep wall, and it's the whole wall around the whole building is 20 inches thick. And so that allows more light to kind of come in and sort of flare out, and also just makes a nice feature. Both of the bedrooms actually have 2 walls on the exterior, and so you could potentially have windows to the right-hand side behind the bed, although that'd be a north-facing window. So again, because of the budget restraints of the project, we only did 1 window per bedroom. The lower right-hand photograph is also a bedroom, but because this was a single couple with no children, that's been used as an office and studio space, but that would otherwise be the bedroom. And again, could have a window to the north if so needed. So we collaborated with a local solar company called Nunatech Solar and Rich Strongberg of Western University, who's an instructor there at the MEM program, which is the Masters of Environmental Management. He was the one that turned us on to on-set monitoring data equipment. And so he took on the project of inserting these temperature and humidity monitors, about 20 of them, throughout the whole envelope. Now, we were somewhat responsible with our innovation on this project because we were doing one of the first straw bale cell hybrids in this community, and definitely the first one that was done with student and volunteer labor. Excuse me, sorry, the second one was done with student and volunteer labor, but the first by Habitat. But we were doing a novel system which was sheathingless, which we'll see in a later slide, where basically there's no sheathing on the building. Our shear is obtained by using diagonal strapping over the top of an air barrier and water barrier. So on the bottom, you can see the 3 monitors that we've inserted at different depths into the wall. So the 3 of the walls, this east, south, and west walls, are all straw bale with 6 inches of cellulose on the exterior, and then that membrane from a Proclima Mento membrane from 475 Supply out of Brooklyn. And so we had those temperature and humidity sensors at 3 different depths to sense in all walls what was happening. The north wall actually is all cellulose, 20 inches of cellulose. So that was like, we were trying to figure out, like, you know, how the different envelopes perform and how the different aspects and walls perform over time. The south was definitely the most interesting, and there was a question from a senior engineer called Alex yesterday about, like, the amount of sensors we used and relative humidity and where we placed them. But basically we stuck the sensors within the installation, and this was built in 2019, and so we've had 6 years of data now, and I can tell you the building's performing very well, and it's, in terms of like moisture mitigation, it's got a rain screen, so it's a highly airtight but very vapor open system, and we're very happy with the results and the performance of the buildings. And I should mention in the other picture here, you can see the solar, but there's actually in one of those boxes is an electrical monitoring system. So every circuit in the house has its own individual monitoring from an organization called, or a company called Emporia Energy. So we're not only able to know how much energy the house uses and how much solar is produced, but also how much each appliance uses. And we have water monitoring to monitor the amount of water, the amount of hot water, etc., as well as indoor air quality. So yeah, this was the second building that we built for Habitat and with Habitat, and kind of building on the success of the first, as you can kind of see on the left. And this was a 3-bedroom, 2-bath. As you can see, it got a different award from Green Build magazine. This was during COVID that we built this, so we had a lot of challenges to figure out on this one. The painted siding is actually cement siding that was donated. Typically, we would use local wood materials or a lower embodied energy material, not cementitious material. But because it was donated, we were like, it was free, and so we took advantage of that. But a very similar envelope system, which we'll see the inside of soon. Both are single story, both have a vented attic in the top, with the heating and ventilation supplied by a combined system in the attic. That's the front of that house. All the houses have a south-facing main roof. And so again, we were able to at least cover the energy needed to run the all-electric home with a 4 or 5 kilowatt system. I'd argue you could make them bigger if you wanted to use more EV or you had some other energy needs. But we worked with Rich and with Nunatech and with students to put these on and design and install them in a way that was appropriate to the demand needs. Again, this is an interior shot of the 3-bedroom house, and you can see the plan on the side. The only real difference between this and the 2-bedroom is there is a bedroom in the top right and a bathroom for the master. Again, with all that gray wall surface area in the interior, that's all plastered. We actually made our own plaster boards for this project versus the lath and plaster, clay plaster we used in the first project. Again, this is more another interior shot. Again, we built created these cabinets for us at a reduced cost. We had heat pump dryers and conventional appliances provided by Whirlpool. We have a working relationship with Habitat for Humanity in general. So they provide electric stoves and dishwasher in this case, and refrigerators. Just a note on heat pump dryers, we've had mixed success with them. It's a very airtight house, so it's nice having a condensing dryer that doesn't create negative pressure by exhausting to the exterior. But we've found that they're a bit of a challenge to maintain, and at our high altitude, some of the electronics have issues over time. Lessons learned. Again, this is another shot of that kitchen, in that gray plaster. And we didn't only just try to make an efficient home, as I described. We also tried to be very cognizant of our embodied energy and our transport. We had one student in particular who did his thesis on the habitat houses and did a lot of carbon accounting. The thing about carbon accounting is it's at the time, this was like 4 years ago, it wasn't quite as developed as it is now, and the tools still had some gaps that are being filled in at the moment. But this is part of why we got our low carbon footprint award from Habitat, was because of our attention to doing these studies to make sure that we were actually accounting for materials we put in. Our original estimations for the first house we built was actually at the time of occupancy. With our material choices, we actually were a carbon negative project. And we learned later that all the volunteers commuting, and particularly in large vehicles such as trucks, to volunteer for the site actually had quite a large impact, which just reinforced our mission of empowering EV and electric vehicles, because we're like, well, actually, one of the biggest impacts in construction is still transport, and very controllable by the individuals who in general. And so having net positive homes that produce more energy, that allow for EV charging, being EV ready, became all the more important an issue, as we recognize that having 30 volunteers drive their own vehicles to the site on a Saturday for a build actually had a huge impact. So just again, more of a point to underline the fact that transitioning away from fossil fuel vehicles is really important. And this was that same house again. This was our crew of volunteers and staff from Habitat Gunnison Valley. The timbers that you see there were harvested within the region. This was a shot of the streets. This is actually a community that Habitat has been able to build on for the last several years. And so you can see 3 of our projects that have this net positive impact. But you can also see the previous 2 houses, which we went back and retrofitted solar to. You can also see that solar is kind of a little bit patchy, as Rich Strongberg works with an organization, or has created an organization called Equitable Solar Solutions, and they not only donated the material, but a lot of their time, students' time. So we don't always get the matching or the prettiest solar panels, but they have a program where they recycle solar panels for community use, like this situation. This was the 3rd home, just some of the aesthetic details, and also trying to work with durable materials. The steel rusted metal is obviously for those of you who aren't familiar, but in mountain towns is a very fashionable finish at the moment. But actually it's very practical. And so while the steel itself isn't made in our local community, the rolling of it into corrugation is. And by just using raw steel and adding a vinegar solution, we're able to patina it and not have any toxic paints, because often paints associated with painting metal have a really high impact, both from terms of energy, but also from a toxicology perspective. So going with that aesthetic choice, while steel does have a high embodied energy, as a long-term durable material that doesn't require maintenance, there's a reasonable trade-off there. So we use it for siding in this situation as well. This was the interior of that 3rd home. We focused a little bit more on wood finishes again. We did a lot more trim work on this house. The floor, unfortunately, is not wood. It's a polyvinyl, it's a PVC vinyl plank. which was affordable, if not the ideal impact. Something we actually experimented with this project was using OSB as a finish. And so we sanded the OSB subfloor, did a really nice finish on it. And I really liked it, but it wasn't to other people's appeal. So in the bedrooms, we plastered from 3.5 feet up, but we did wood paneling, again, local lumber that we sanded on site and did a clear finish on. So the bedrooms all had this more durable lower wainscoting. Again, lessons learned in the previous homes, especially in children's bedrooms, having plaster low down proved not to be as durable as we would have liked. And so having this wood allowed us to take a few more knocks. Now we're kind of going a little bit in reverse, but working from the foundation up, not on all of them. We tried different projects as we were always looking to try different approaches and new materials. And so, but on the first house we built, this was a cork material we used for the foundation. Now, cork also has a negative carbon impact by time of arrival, supports a fantastic industry and ecosystem in Portugal. So we're very happy to be using cork. This was a similar project that actually wasn't Habitat, but a local builder who volunteered with us took the techniques to build his own home. This is a shot of the outside of the house showing the sheetingless system. So essentially there's a stick frame is stood up like a standard wall, and then you wrap it in WRB, an air and moisture barrier, and then you apply diagonal bracing over the top of it, which gives the shear, but also creates this vented cavity for the sheeting to go over, or the siding to go over. Going at 45 degrees gives you the option of going vertical or horizontal with the siding. The roof was a skip sheathing system, like an old traditional roof. This gives you a little shot of that double stud wall system. We either installed all cellulose or did a straw cellulose mix. Again, very vapor open, but airtight. All these houses, when we did blower door tests, and this was using students and volunteers, very few experienced high performance professionals. All these homes got a blower door test of 0.4 ACH50 or less. Just some of the details of how we dressed the windows and the doors. You can see cork used there for some thermal breaks around the headers and jambs. This is a shot of the inside of the straw bale cellulose wall system. We ended up, because there were so many windows and doors and there was so much framing, we ended up actually just framing the exterior wall and not having free form plaster on straw bales, but going over it with lab plaster. Excuse me. And on the top right is an example of our clay wall system that we developed, which was basically making our own drywall panels, but using clay plaster and jute burlap. And so we made these 2x4 foot panels. On the flat, we would dry them out in drying racks, and then we would install them using drywall screws. You can see we've mudded and taped all the seams with with the gypsum quick mix. Again, an exterior 20-inch thick wall. We use a drop ceiling below our trusses to make sure that electricians make very few penetrations through our barrier. You can see then just the finished ceiling being installed. Because of the size of our ducting for our HVAC, we ran above in the attic with our ducting. And there's an example of that. So we have mostly 8-inch trunk duct, trunk and branch, 6-inch branches. So we supplied the fresh air to the bedrooms and living areas, and extracted our exhaust through our balanced ventilation system from the kitchen, laundry room areas. And this was our first blower door test, 0.32 ACH50. I think that was one of the lower ones we got. Again, a very small building, but very low CFM. And this is one of the students. This was the peach color one of our clients chose, just proving it's actually peach. And this was the most recent. I actually wasn't involved with the design and the management of this build, but they adapted the design and the envelope system we'd used to build two houses at once, and went back to the wood-sided finishes. So this wasn't constructed by our company, but beautiful work done by the crew that took over. I can stop for a minute too, because we can move on to the next project, or if people had some questions for a couple minutes about these habitat projects, I'm happy to answer now.
Yeah, the straw bale kind of conversation came up a little bit, and I think obviously we have a lot of people building in what we would call the sort of cold, wet climates where it becomes more challenging, I think. So I think they just wanted to hear from you just on, again, how you're, ensuring that straw bales, not rotting, not having mold issues, and whether you have any suggestions this, in these other climates that are a little bit more harsher towards it as well.
Yes. So the first thing I'll say is there's a reason why I love Colorado. For 250 days of sunshine a year and barely any rain, it's my favorite climate I've ever lived in. So when it comes to moisture issues with housing or with construction, there's really two phases, right? There's the actual construction process, and then there's the use over time, the actual occupancy. So I would say, excuse me, once you detail a house correctly and you understand building science principles, really straw bale is, or straw as a material, is appropriate for almost any climate and any application above grade. It's the construction process that really the climate hampers the most. And so I think one of the solutions for that with using straw as a building material, and a very regenerative one, is offsite manufacturing. And so that, in my opinion, that's really the future. There's no other way that the housing is going to go, or just construction in general, which is climate-controlled offsite manufacturing of building components and modular housing. In which case, straw, there's really no excuse to not use natural materials such as straw or hemp, or other materials that are more susceptible to moisture. And the thing is, with these vapor open envelopes, we're using wood, cellulose, straw, hemp, and they're essentially the same material. They're just assembled in different ways and different densities. So a piece of wood will also rot if you get it wet. It'll just take longer than a straw bale. But they're both predominantly made of cellulose and lignin. And actually, straw has a lot of silica in it as well, which is part of its fireproofing properties. And so I can only imagine that straw will become a more predominant building material in the future, especially when that aspect of construction and weather damage is mitigated by offsite manufacturing.
Great. Well,
and I should actually mention too, part of our choice for straw bale was carbon sequestration or sequestering. And so when we're trying to actually create buildings that are climate solutions, we want to pack as much carbon into the building as we can. And the easiest, cheapest, lowest impact way to do that, and also from a financial perspective, and the most locally kind of circular economy way to do that, is to use local straw bales. But you can import panels now from Canada that have straw in them, cellulose, hemp, whatever you want in them, and they're literally just plywood boxes. And so it's very much going into the realm of high production. But again, using local straw bales from local farmers is the way to best impact your local community.
Well, I want to invite anyone who didn't get their specific question answered about straw to re-ask it, and we'll come back around to it later. There was a lot of chatter and conversation, so if something was missed, please bring it back up. But I think you made a good segue on carbon, embodied carbon. You mentioned low carbon. Now, in a lot of these projects you built, that was before I think the trend took off in 2021 of the term embodied carbon, upfront energy. It became a big talk. So I think I just noticed there. I mean, we've been talking about it forever, right? But it just became very trendy around 2021. And so now there are a plethora of embodied carbon modeling tools, just like we do energy modeling. Is that something you actually look into now? So then just making statements like, oh, this is low carbon. Do you actually approach projects with looking at an embodied carbon and actually modeling out and seeing what your true impact is?
Absolutely. So we've used a variety of tools. Excuse me. Predominantly the beam tool from Builders for Climate Action, which I highly recommend as a resource. They've been industry leaders in building tools that are available to both builders and designers. So like I said, originally we used the version in 2019 for that first home. Um, the readout we got was that our house was actually a net negative carbon impact. So by building that house, we actually reduced carbon in the atmosphere. Um, the devil's in the details. You really have to make sure you do accurate accounting. And one of the challenges with that is industry sources aren't necessarily great at giving accurate numbers. So, for instance, plumbing and electrical for a long time has sort of kind of been ignored as a impact because it's very hard to account for it. But it's not negative, that's for sure. So, kind of as a rule of thumb, and while studies and data is really great, we just try to use as much local lumber as we can, use as little transport as possible, and jam pack as much carbon-based natural fibers into a house as possible.
Great. Well, let's move
So-
on to some of your other discussions, and then we'll
Really?
circle back to the questions. So thanks.
Yeah. Previous to living in Colorado, I lived on a Hopi reservation in northern Arizona and was part of a student build there, an amazing organization called Hopi Permaculture. They're kind of very more community focused, but they have a building program, so they do a lot of like agricultural stuff. But occasionally they'll build houses for communities members in need. And this was 2016. I was hired to come in and bring my skills to the local workforce. This was mostly all at least 18, but we had 18 years of age. But our students on this project were 18 to 30 or so. And we had about 20 students throughout the 8-month build. And this was definitely a project I'm most proud of and just had the best time on, and partly because of the community that I was in and the need, but also their openness to new ideas and labor. They were really hard workers and really into craft and art, not just their traditional, but also bringing like permaculture techniques and natural building techniques into their community that hadn't historically been developed there. So it was a really beautiful hybrid. And super low cost. Basically, the material cost to the homeowners themselves was $50,000, and granted, this was 10 years ago. But what you're looking at, like the stone, the plaster, there was straw bale, a lot of cob, like adobe construction came from within like a couple of miles of the site. And straw bales are imported, but a lot of the materials they quarried their own stone. And in the bottom left, you can see some of the artwork that some of the students did on the walls too. This was the plan. Each one of the homes they built usually incorporated a greenhouse for growing. So again, thinking more like from a permaculture perspective, thinking from a homestead perspective. This was a simple house, like 3-bedroom or 2.5 bedrooms with 1 bath, for a family of 3. The people who moved into this had only ever lived in trailers on the reservation, and aluminum and old poor quality trailers, which, as you guys are probably familiar, are very cold in the winter and very hot in the summer, unfortunately. And so this was a huge game changer for them. And even just from but particularly from an indoor air quality perspective, this was a very different building than most people were used to living in that community. We're looking at adobe walls in the interior, mass adobe walls. Again, the stonework, you see that was hand quarried from the cliff faces, from the mesas. The logs were all processed by the students, brought in from a local forest. And that's an adobe floor. They do beautiful plaster and finish work in this program. This was the finished kitchen. We built everything, including the cabinets, from scratch using local ponderosa pine. Again, some of the little details, the niche details in the adobe walls. We did a Cadillac plaster bathtub or surround on the bathtub. And this was the crew. It took about 8, maybe 9 months to build in the end, totally solar independent, off grid. Hopi Permaculture has relationships with a solar Solar SEI. I'm trying to remember. Anyway, Solar International, something Solar International, and they came and built with over a couple of days the solar program or the solar system with the students. Yeah. Any questions on that? SEI, what is that? Solar something international. They work a lot on native lands, doing programs like that. And I can keep moving just for the sake of time. So this was a project that myself and a partner did in North Carolina in 2015. This was basically utilizing the building, the allowances for building in Greensboro, North Carolina in particular. Excuse me, let's take a drink. We elevated the building up on stilts to be able to take advantage of covered space underneath, but not have usable square footage area. It pushed the building up into the forest, named the Roost. This was an attempt at having very low embodied energy, but useful additional ADU space. Actually got featured on a TV program called He Shed, She Shed, and so they helped with some finishes. So some of the tables and chairs and stuff in here were provided as part of that financing from that show. But this uses a heat pump, mini split for heating and cooling. Again, if we didn't do particularly accurate numbers on the carbon accounting, but we avoided pressure treated lumber as much as possible, low toxicology, and we avoided foams, plastic as much as possible, and used a lot of cellulose. Also a lot of reclaimed wood. Pretty small space, so there wasn't actually a bedroom as such, but there was a bed nook that you can see on the right-hand side. Again, like a lot of reclaimed materials in the kitchen. Bathroom, we use some reclaimed metal for the walls. Yeah, very cozy little space. It's available on Airbnb if you ever go to North Carolina. Yeah, and there was a little outdoor deck space. This was actually the only time, or one of the few times, I've been involved with design and construction in a hot, wet, and cold climate. So it was definitely a challenge to design the envelope, and one that was unique to me. And we wrapped the whole thing in this cork siding, so it has insulation, but also acts as a finish. But yeah, the hot, humid, and cold, humid climates are definitely challenging. But again, like with good ventilation and with good detailing, no reason why you can't use natural fiber-based insulations and structural products. This was going back before that. This was a house in Vermont, in Granville, Vermont. When we inherited the project, it had an existing timber frame that had been put on a foundation. So we actually had to lift up the timber frame and insert a floor system underneath it, and that we put cellulose insulation into. Again, this was a double stud frame, which is definitely my preferred method of construction when it comes to envelopes. I don't think there's a cheaper, better, more flexible way to build a high performance envelope, especially a vapor open one. Once you get above grade, in my opinion, there's very few situations other than very flat roofs where natural fiber insulations aren't appropriate. Basically foams above ground, I think, are almost never appropriate, particularly ones with high global warming potential, which we'll talk about in the discussion, because it's not just about saving energy, it's also about, it's in the end of it all, it's really about our impact on the environment. And if we're using materials that have high impact on the environment to save energy, then what are we actually doing? And so this house had, I think, the last fully timber passive house certified windows that Clearwall made out of Ireland, just by coincidence. And so these beautiful wood windows went into this house. This was, I think, a 16-inch cellulose wall system. Again, passive house standard levels of air tightness and insulation performance. And we used a Lunos HRV, which is a spot HRV. So not a balanced centralized system, but a pairing system that uses two. I believe we had 2 lunos in each floor, and then 1 in the bathroom as well. So 3 total. Again, we had like the client wanted to have a foam and formaldehyde-free envelope, so we used local lumber that was milled and within 20 miles of the site. And very little concrete used, grade beam over rubble trench foundation. This was the design process. I would give a shout out now for this was 2014, so still kind of maybe the early days before Revit had been fully adopted by a lot of the architectural industry. I've used SketchUp, I still do, partly because it's very flexible, unfortunately not particularly automated. But so this whole house and most of the houses I've designed and built, I do something I call construction modeling, where you basically build everything within the house, including trim details, so that when you go to build it, you've actually, or build it physically, you've actually, as a builder and a designer, you have a very strong idea of how everything's going to go together and avoid conflicts with things like mechanicals and utilities. When it comes to affordable housing, I always try to stress like there's no affordable housing unless you integrate your design build processes. The more subcontractors, the more specialists you have, the more expensive a house is going to be, no matter what materials you use. And what our experience has taught us is that a lot of affordable housing is really just cheap, poor quality, lowest bid housing. The only way to really get affordable housing is to have an integrated design build process. And when you do that, then you get a way higher product. And so we are big on advocating for educational programs and that emphasize that cross-disciplinary experience, whether it's different trades or just simply having design professionals who understand how to build, which is often not the case. And so this is a really powerful tool for doing that. And you can see examples of that. And this is on the right-hand side, you can see the timber frame that we raised after it was built for less than a year, which is usually not typical. We built a bridge truss to lift the whole frame out of members that we then reused for the structural timber frame on the inside of the addition. Again, all locally sourced finished materials that you can see. And that's it. Yeah, I would love to have discussion and open for any questions. I know there's a lot of information in there, and I will say I have a lot more other videos, presentations, and a lot more information that I hope Brett can share with anyone that's interested about getting really into the weeds of these projects. But they're, houses are not, well, these houses in particular they're not simple systems. They're very complicated. But if you do design build, you can make them pretty seamless to build and get a really strong understanding of all that as you're doing it.
Great. Well, thank you so much, Cillian. We're going to stick around for some more formal Q&A and questions. But Debbie, I know you were going to take us briefly through some other projects, and I just realized I never loaded those up. So I don't have them ready to go.
Well, I'm
But I just
seeing.
didn't know if you had like an overarching idea as I put this together. So
Okay. Well, yeah, that's a hard act to follow with those projects. And I would say the other projects that we're going to be talking with would all kind of strive to use those sustainable, low impact, low carbon materials. But for whatever reason, lack of professionals that are knowledgeable in the area, sometimes lack of a willing client, you can't always do as much as you would like. And I think all professionals that are involved with these kind of projects are always pushing for more. But these other projects that we wanted to show are projects throughout the U.S. where people are trying to do a lot more. And I'm really impressed with Habitat in general. When I see a project where Habitat is striving on this low budget, if they can do it, then all arguments for other people with more money, just to me, it just goes out the window. So I guess I might just start going over a few of them while you're
yeah, and
looking
I'm
for
glad
the
you mentioned
slides,
Habitat,
Brett.
because I do have the Grand Traverse project here that now pulled up. Can you see that?
Yes, yes. Okay. So, yeah, so that one there in northern Michigan, a very active Green Home Institute member told us about this one. And this is part of the US DOE Zero Energy Ready program. They were a winner for housing innovation. Um, and it's all electric, minus HERS rating, -1, very low energy bills. And that's in, I believe, Climate Zone 6. So I thought that was a very impressive project. Yeah, I don't want to spend a whole lot of time reading what's on the screen because you can all go back and see that. And I have a feeling we're going to have a lot of questions for Cillian as well. But you start to see a lot of patterns of higher efficiency windows, cellulose as much as possible, continuous insulation applied to the outside, photovoltaics, of course. Um, Go ahead, Brett.
Nope, nope. I was nodding. Yep.
Oh, okay. Yeah, and this one is one of my favorites. Dr. Bing Chen, this is working on this with his students, another student designed and built project. So similar to some of Cillian's that are getting involved with students, I think this one is also very cool. This is an ADA compliant, very small at around 400 square feet, and they are doing extensive monitoring as well. And I believe the basement incorporates cistern, and they're utilizing the thermal mass there. And we hope to see more of their project. I believe they're presenting at the Solar 2025 in Boulder in August, and we hope to hear a lot more about that project later. And maybe we'll have them on the GHI ACES webinar series in the future. Next. Yeah, so here you can see the tiny square foot, the amount of direct solar gain that they have, high insulated walls at 45 and 84 roof, and super high window, about as high as that's available. Next. So, yeah, I guess this is just summarizing the pillars that all these projects are aiming for: small, sunny, sensible, and simple, the four S's. And there's a lot that can be, a lot of floor plans and designs that can work within those four pillars, if you will. And Brett, I was going to ask you at this point, do you want to talk about the Green Star Homes checklist that people can use from the GHI website to help them with their projects?
Yeah, absolutely. So I'm just going to be very brief here and say that, as you're putting projects together, we have an open source tool that you can use. It's completely free to use. The manual is available to give more information and detail on how to achieve it. So if you're looking at a way to get organized and a place to start, we have that all available, and it can, you can achieve certification as well. So that's on our website, and I'm going to drop a link into that into the chat there for you too. So but yeah, with that, I want to make sure we have a lot more time for questions. And before we get into those questions, just a quick reminder to everybody here that yes, this session is being recorded and will be posted on our YouTube channel in the next couple of days. You can wait and check back then when it's available, or you can go there now, click subscribe, ring the little bell, and you'll get a notification when this session is available to rewatch, share with your friends and colleagues, or catch anything you missed. For those of you watching this in the future, but not right now on demand, make sure to take your quiz with an 80% passing rate to receive your continuing ed certification. For those of you who've been here live for the entire CU approved hour and you're logged in appropriately in Zoom with the name you want printed on your certificate, take that survey that pops up at the end when we close out, or it'll be sent to you if you miss it. Put in your AIA number there if you need that reported, but we want to get your feedback one way or another. And then check your spam over the next couple of days at certs@gutenbergcerts.com. You will receive your continuing ed certificate there. So let's start getting into some of those questions here. And before we do, a huge thanks to our board of directors, including Debbie here, our volunteers, our executive director, Jose Reyna, and our sponsors who fund us to allow us to do what we do. And they're making products to help electrify, decarbonize, and achieve more sustainable outcomes to do that. So really appreciative of their support. But yeah, we're going to get into questions, and we're going to go a little bit later with questions today. So if you got to go ahead and leave. You're dismissed. But if you can stick around and engage in the conversation, we want to get to a lot of these questions that are coming in. And I want to go back as Cillian, to the uh, conversation on the specifics of integrating with your wall system. So here's a very detailed question. So first, the person had made a comment. They said, looks like a mento membrane is applied directly onto the stud. So I believe that is a breathable, in other words, a breathable membrane. We'll just, without mentioning products, I suppose. And then covered with a layer of 45-degree furring strips. So again, this is a comment. But the question is, any concern of the membrane tearing with no sheathing layer supporting it, especially during construction? How do 45-degree furring strips provide ventilation drainage plane behind cladding? Are they perforated?
So great question. I have no problem pushing these products because they've 475 buildings, high performance building supply in particular, has been an amazing leader in high performance and ecological construction, and always happy to promote them, and also just a wonderful business. So they provided the Proclima Mento, which is a German product, which is a perm of 40. So it's highly vapor open and a great place to put it on the exterior. Yes, during construction, it is challenging to not damage it. We used their 3000 version, which is a bit more durable. Working with conventional professionals in construction, I have been hesitant to use that, and because the details require a lot of training and not to be pejorative, but like contract or general carpenters are not always the most delicate people on site, and so like it is something to be considerate of. Like, is this product durable? And if someone punctures a hole in it, are they going to report it to the site supervisor, or are they just going to move on and put the siding over? And so if I have full control, full design build, and I'm running the project, I'm a lot more comfortable doing that, like I did with Habitat. If I'm a consultant or a designer only, then I have not advocated for that system again because of its lack of durability and the likelihood of damage and people not reporting it. So we've gone to a plywood and Adhero system. Adhero is a peel and stick product from Proclima as well, which has a perm of 8, which is very similar to plywood. So not as high as 40. My dream product is a sheathing product that has a perm of 40, and you can just tape the seams. It's always been sad to me that Hubbard zip system doesn't make a plywood version of their system, because they have OSB covered in a coating that has high permeability, but OSB does not have high permeability, so it's kind of pointless. But yeah, so the idea with the 45-degree strips is it is a bit of work. It works very well. If you're building your own house, I'd highly recommend it. You get a lot of benefits, including that breathable rain cladding screen out of that. So if you have more time and local materials than you do money for labor and such, or you've low labor rates, then go for it. If you have high labor rates and conventional carpenters, I would not recommend doing that system for that reason. Functionally, it works great. You got to make sure you detail it too. We have had one issue where we ran into a rodent intrusion through a roof barrier because it wasn't detailed correctly. There was a part where they were able to get access, but typically we do a pretty good job of making sure rodents and insects don't get inside and rain screens and such.
So, it stood out to me in the very first project you were showing us about how you mentioned you would increase the square footage? Because a couple things, obviously. Number one, the biggest alert that went off in my mind is probably from the time you built it to now, costs have escalated, exponentially, to add any more square footage. And then number two, of course, when you add more square footage, you have to condition it, so there's more operational usage, there's more embodied carbon. So I guess my question to you is then, you know, do you consider what we call right sizing of homes and using strategic design strategies to have smaller footprints? Are those things that you've used? And did you get a sense from the occupants that it was, just too tight, I guess?
Yeah, I mean, that's really nothing to do with ecological construction. That's really just design. It's purely a design conundrum, is how do you keep the usable square footage? Because one of the problems is a lot of metrics, including real estate, use exterior square footage for their metrics. So they're like, oh, you have a 1,000 square foot house. But then if you build a thick, well-insulated passive house wall, then you lose like a couple 100 feet or 100 feet of that area. So, I can't change the real estate industry, but with our drawings and with the initiatives we're working on locally, we always advocate for differentiating between usable square foot and footprint. One way around is if you do exterior insulation, such as a Larson truss system or TGIs, most building officials will take the footprint of the foundation as their square foot basis, in which case you can actually take advantage of that and do a 2x4 wall, so you can actually gain a couple inches back and then put your exterior insulation off the outside of that. But again, the two metrics are, the most important metric is usable square footage, in which case it doesn't matter what your envelope is. That's just really a design question. So in that situation, yes, the homeowners found it was a little bit tight for their liking. And but we were also not the first home, but all our other homes were also ADA compliant. And so that's another thing, which is a tension, is if you want to have an ADA compliant home, you're going to have a lot of extra space that you have to account for. That's a large bathroom, large corridors, plenty of room. Even when you need 36-inch doors, you need 3-foot doors in the interior. And so we set that as a standard for, in where I was trained in Ireland, it's called universal access, which is, I think, a better term than ADA. But if you do set that as one of your goals, then you're going to have more space, or you're just going to have you're going to use more space. And so with the 3-bedroom model that I showed you, we actually managed to be ADA compliant and get 3 bedrooms and 2 bathrooms and an ADA compliant bathroom into just under 1,300 square feet. And that's exterior. That's not even usable square feet. So I think that design, while like I said, it's tight, was pretty remarkable that the design team and the students who were part of the design team were able to pull that off.
So, on the note, the other part of a question that came in, of course, is always, how much do these kind of homes cost? Cost per square foot, cost in general, and comparing it to, when it was to where we are now. One thing I noted, you had mentioned, like, I think on the Hopi project, a 50 or some kind of mortgage, which I think that's always great to put it in those terms, right? Because no one's going to build these homes unless they have a mortgage that is affordable at the end of the day. That's what it's all about. So, obviously it's a loaded question when you ask someone costs, and everyone answers it differently. So what is your response to, how we're going to be able to achieve these homes, in a financially sustainable way?
That's a whole different topic that's actually, again, got very little to do with environmental construction or ecological construction. It's really a financial question. And my experience is a lot of builders kind of the financials, at least historically, have been a bit of a black box. And if someone will pay $800 per square foot for a house in a desirable area, then that affects construction costs, right? That affects labor costs. Kind of the long story short is basically I'm a big proponent of design build and financial transparency, because if you don't do those steps, I don't think you're going to have any change in the industry. You're not going to be able to provide community-based housing, ecological housing, housing that has like other metrics beyond cost if you don't create transparency, number one, and create integrated project delivery. And so, with our educational initiatives, that's always what we try to focus on, is making people energy literate, making people financially literate, making people have business acumen. If you don't understand, how the finances of construction work, you can only impact it so much, right? It's such an important resource. So again, when I mentioned resource conscious construction, obviously money is a huge part of that. And so when people talk about affordable housing, most people what they're talking about is cheap housing. And there's a whole industry, a nonprofit industry designed around that essentially works very similarly to the for-profit market rate industry, except it's subsidized by local governments. And that's you have a development company that comes into the affordable housing, but they're just a development company, and the only difference is their profit is coming more from local governments and subsidies than it is from the market. So that's a huge topic that I just don't want to go into. But I will say that the way we were able to deliver the habitat houses are a better example. The first house we built was $180,000 to the homeowner, which didn't involve the cost of volunteer labor. It did involve my design and management costs. That was 180,000. The 3-bedroom was then 220. Next year, I think it was closer to 250. And that's just increase in material costs and also subcontractor costs. But the way we were able to keep those costs that low was because we essentially, I was the designer, the builder, and the project manager. And that's not a credit to me. That's a credit to having those three things integrated, that design build model I was talking about. And so when I'm designing, I'm thinking, okay, if I put one window here instead of 2 windows, that's less openings, that's less framing, that's less detailing, that's less labor, that's less time, that's less materials. That's going to save money. And an architect or a designer will not necessarily be aware of what entails for the detailing or the framing. And then when someone receives a designer's drawings, they may not be able to affect, they might know that answer, but not be able to affect the design. And then also on building it. So when there's stuff that comes up on site, and especially if I've done the construction modeling I described, a very strong idea of how to build this. So that would I'd say that I'd advocate the only way to do affordable housing, regardless of whether you have ecological goals or performance goals, is through integrated project delivery. And if it's a small custom house like a lot of these are, then one person doing that is the most efficient way to do that. Yeah.
Yeah, fair enough. So the other one is kind of going into window preferences. If you can just go into a little detail on that. Are you using double, triple? What are some of the barriers to using triple if not?
Yeah. So all the projects that you've seen, with the exception of the Hopi project, all have passive house certified windows.
Oh.
I basically don't bother with any other brand because particularly the American fenestration industry is notoriously obtuse with their data, and so what you want is center of glass is a useless term. If they the R value of this window or the U value is center of glass, I'm like, that doesn't matter. I want to know how much the overall R value is of the window. So when I'm designing, when I'm doing my modeling, my energy modeling, I can say I have 2,000 square foot of wall and I have 100 square foot of windows. I can just literally put in a total R value. So with passive house certified FIAS or PHI certified windows, I know that their performance, their thermal performance is great. I don't have to think about it. And then I also know it's going to be airtight, so I'm not doing a blower door test and wondering why my numbers are so low. So I just advocate that basically as a minimum standard should just be passive house certified windows and doors. I don't even bother with any other manufacturers or any other people who don't have that certification. And so most of the windows and doors that I've specified are Alpine windows out of the Front Range or Longmont, I think their new factory is. and they manufacture or assemble both PVC and fiberglass windows. And so
And
to speak to one of the other comments about PVC, we try to avoid PVC because it's a really nasty material,
yeah.
but it is cheaper typically. So we've used fiberglass windows, which are more durable as well, particularly in sun-dominant climates. But they don't make, but then like they don't make a fiberglass door, so we use their PVC door. But anyway, they are typically like they're definitely more expensive than conventional windows, depending on the finishes. But again, when one person is able to do like horse trading, when I can, okay, I'm going to put more money into windows and doors than typically people would do in a project, but I can save that somewhere else because I have full control of the design and the build, then I can essentially produce a house for the same cost as conventional construction, but way more high performance
Sure.
and better ecological impact. Yeah.
There was a specific question on the R7 wood window you mentioned. Where are you able to obtain those from the Vermont
Like I said,
province?
we got the last batch that Clearwall made of all wood, and they're
Ah,
beautiful, beautiful windows, so well made in Cork, County Cork.
yeah.
But yeah, they stopped making those particular windows. I think we got the last batch, and that was 2015. So.
Okay.
But I should say there's plenty more competition for windows and doors, passive house windows and doors now than there's ever been. We've had a
Do you
lot of
see wood
success.
ones?
Yes, so
Yeah.
the best ones out there right now that are very competitive and beautiful is a solid 4.5 inch wood frame and made by Fenster in British Columbia on Vancouver Island. And they use local fir there, and it's basically there's nothing fancy about it. It's literally just 5.5, 4.5, I think, inches of fir, and that's got enough insulation, and they use really good IGUs that's passive house certified or very close. And because it's just a simple frame, you just put screws through it. It's great. It's nothing complicated. It's a giant 4x4 basically is the frame. Yeah.
And you mentioned cork earlier. Someone was just wondering where you're able to find that kind of the cork.
Yeah, cork
assembly.
is the best building material I've ever worked with. And like I said, when people ask me how to how would you best impact the environment and human society as well, I'd say buy cork. It's mostly produced out of Portugal. Supports multi-generational, multi-gender family business, small family businesses. The most ecologically diverse system that humans have been involved in or managed. There's some great. If you look at Patrick Spencer on YouTube, he came from the wine industry where he was helping to dispel myths about cork forests being destroyed when actually we need to use more cork to preserve them. But it's a fantastic building material. The only challenge is it's expensive. So it's not something that can be used, like in a wall system as just the only insulation. You should use it somewhere where a delicate, rigid insulation is preferred, like I showed on one of those thermal bridges. So I love cork. It's a fantastic product. Yeah.
Yeah, and there was a specific question kind of getting into like if you have any a little more detail on breaking the thermal with the cork, and I'm saying the question incorrectly, but could you please speak more to share detail for window thermally broken with the cork? Several homes you discussed, including the last one in Vermont.
Yeah, so we have double stud walls, so we have two different layers of framing, and there's horizontal connectors tying them together, particularly around windows and doors. And so on a few of those projects, what we did was we added a strip of cork, screwed on another framing member, and connected that back to the interior. So essentially, the interior and the exterior of the double stud wall are thermally broken. I don't do that anymore. The reason is if depending on your depth of understanding of building science, essentially when it comes to excuse me, I gotta take a drink. And when it comes to heat loss, I don't worry that much about thermal bridging if the overall R value of the envelope is the average is good, then I'm not worried about like thermal bridging. I think people get too obsessed with thermal bridging. The thing I do worry about with thermal bridging is condensation, because if you have a cold member and you have a warm, moist, but if I have a vapor open envelope, which is what I always advocate for, then if there's some condensation and I have it surrounded by, but basically if I don't have much steel or any steel in my envelope and it's all wood, straw, cellulose, hemp, then any condensation that happens will be quickly absorbed and distributed by that envelope. And as long as it can dry seasonally, we've never found any issues with it. I will say though, 1 inch of insulation is very effective. We learned that. I'd say that the first inch of insulation is the most value, and the last inch of insulation is the cheapest when it comes to double studs. So if you make a 12-inch wall or an 18-inch wall out of cellulose with double stud, there's not really much of a more than a material up cost for that extra 6 inches. But that first inch of insulation does a lot. So I understand why wrapping your house in continuous insulation is a really good strategy. The problem is it's expensive, and it typically plays right into the hands of chemical foam companies and kind of the norm of get or done conventional construction. I'd much rather see a double stud wall, which is cheaper, and then see, foams wrapping houses.
Interesting. Well, we, Cillian, are at our time, and so any questions we missed, we're going to send those ahead to you and work with you on responses. So at that note, I guess just real quick, where can people go to learn more, find more resources on what you're doing? And yeah.
Yeah, so my company is Hearth Design Build, and that's hearthdesignbuild.org. If you go to the resource pages or page on that website, you will find the best resources for supply, for education and such. So that's the best resource I can point you to, is the resource page on hearthdesignbuild.org, hearthdesignbuild.org. And feel free to reach out, hearthdesignbuild@gmail.com. I haven't been super on top of updating digital stuff online with Facebook and stuff recently, but we have done a lot of work since these projects, mostly focusing on market passive housing and such like that in this community. And we're always trying to develop educational programs. We're always looking for partners and people who are interested in being involved, and so and always looking to learn. And so I hope that from this, there's lots of new conversations that are generated, and hopefully new relationships and contacts and connections.
And before we wrap up too, a huge thanks to our co-promotional partners for this, American Solar Energy Society and Ella for helping put this together. And make sure to check out their tour this year or next year coming up as well. And a big thanks to our board member and on our education committee, Debbie Coleman, as well, for helping put this together. Cillian, thank you so much for joining us and walking us through this great work that you're doing, and I hope to see more of it. So thank you all so much. Take care, be well, and we'll catch you next time. Goodbye.
All right. So.
Thanks, everybody. Thanks, Brett.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.